Hi, I'm Dan Dick, and this is about how do you learn machine learning? How do you learn it? Why do you want to learn it? There's a mystery to it, the magical thing. How do these computers understand when I talk to them? How does somebody write a program to do that? That sounds impossible. Or how do they write programs that drive cars or fly drones or analyze X-rays and determine, what a diagnosis is for your lungs, for instance. How do they do it? How does this magic happen? Well, a lot of it is due to the machine learning, what's called machine learning or deep learning, which is multi-layered neural networks usually, and there are different kinds of layers. You have your convolution nets, which match little features throughout a picture, for instance, and kind of put them all together to match bigger features. You've got your time-based things, your RNNs, or recursion neural networks. And of that, the most common would probably be your LSTM and your GRU. GRU being the simpler one, but it's very effective, just like the LSTM is. And you have a lot of interesting things to study if you're interested in that, but it can be very burdensome as well. So if you're going into it just to make a lot of bucks and try to find an easy way to just take a quick class and become tomorrow's greatest guru of machine learning, you're in for a surprise. Because the question used to be before whether you could get into this without a PhD or not. And a lot of PhDs looked at that and said, yeah, you can. You can. Doesn't mean it's easy. It just means that you don't have to go in and become, like for instance, an aeronautical engineer to buy a plane ticket, or be an automotive engineer and build, design the internals of cars in order to drive a car. What you can do is you can learn the tools of the trade that people have already created and use those and learn to use them really well. And that's kind of part of engineering. You're not a scientist at that point, you're an engineer. You're using the existing tools to build something practical, of practical value, of practical use. And there's a need for people to do that. Now, people get the mistake that they think that if I'm going to become a machine learning engineer, if I'm going to be an AI engineer, I'm going to be building models, machine learning models, neural network models of different kinds. I'm going to be testing them, experimenting, and doing all this kind of stuff all the time. And it's going to be fabulous. I'll be just focused on that. I don't have to worry about the database, all of the other things. The data, they're going to give the data to me on a silver platter. I'm going to feed it into my network, and it's going to have an output, and it's going to match the output against the expected output. And bang, it's going to come together, and we're going to have a shiny network that can do all the things in the world you can imagine. Feed words into it and tell them what the words are, and it'll be magical. It'll come in and understand everybody's language and translate to any other language we want and everything else. And whoa, hold your horses on that point. That's not where it's going. Now, maybe they'll have the tools to do that. Maybe they have some of those already, but maybe they're in development at this point. But that's not what the machine learning is all about. A lot of people are saying that it's about 80% wrangling of the data, cleaning the data, preparing the data, getting it into the right format to where it can actually be fed into a neural net. Okay, when you go through all that work, you've got to harvest those processes. You've got to make sure that you have best practices for taking the data from whatever its source may be, which it may have many sources. You may be looking for pictures of snails or birds or flowers or lungs with diseases or babies in tummies, brains, eyeballs, anything. And they may come from websites, they may come in different formats, they may come with, you may have sets of data that are more fleshed out than other data that comes in. You may find some data is missing. What are you going to do about that? What are the rules for translating that data or bringing the data in? For sucking the data in, how do you manage that data that's coming in? Because you're going to want a complete solution from A to Z. And once you have this running, everything is running nice and smoothly, suddenly you find a bug in the program and you need to update it. Or suddenly your network is getting outdated and you need to go and refresh it, learn again. How do you do that? How do you maintain this whole environment? What are the best practices? There are practical considerations. How do you back the thing up? How do you deploy the results of this? Here you are creating a neural network. You have data coming in. How do you have it coming in for the purpose of learning? So you're getting your training data sets, you're getting your testing data sets, you're getting your validation sets, and you're getting all these things. Now that you have your network and you want to bring it out into production, what is it going to be? What's going to be feeding that neural network? And what is it going to feed its output to? It's going to be something to receive it. There's an engineering, a package that has to be engineered all around it. It doesn't, the neural network doesn't just live by itself and magically connect to everything or do whatever the things are that it needs to do. It's got to be engineered. The environment's got to be engineered. There's a lot to it. It's not a small thing. And you got to be able to back it up. What happens if you make a change to it? And everything looks like it's working okay, and then a couple days later, bang, it dies. Everything's going wrong. It's producing bad results. You're finding out about the bad results after the fact. What do you do? How do you correct it? How do you go back and correct the errors that those errors have caused? How do you do this? How do you version control this network or the software coming and feeding it or the software that takes care of the data coming out of it? How do you do all this stuff? There's a lot to this. There's a lot to this field. And there's a lot to learn. So what are you wanting to learn now? Let's say you've already been in the field, in the IT field for many years, like I have. If you've been in as long as me, there's a lot of companies that are pretty ignorant about experience. They think it amounts to nothing. It means nothing. If you have gray hair like me, then all your experience is going to be punch cards, paper tapes, programming in COBOL and Fortran 4 probably, or old assembly, IBM assembler language, JCL, oldie moldy stuff. That's what they might expect. Or they might expect you to be fading a little bit, even though a lot of people don't fade until they're in their 90s or even 100. You see some really sharp people at 100. How do you explain that? I think automatically if you're over 60 you have, or 50 or 40, you have Alzheimer's. Not everybody does. What a lot of them have is experience. And they throw it away as if it were worth nothing. As though the person cannot perform. They won't be up to date. They won't know how to use VCode or Atom. They're off on the VI days or Emacs days or whatever. Well, even if they are, I'm old enough to learn those things. What about the other people that are over 60 or 40 or whatever? And if you can learn 20 or so computer languages, why not 21 or 22 or 23? What is there characteristic about Rust or Python that isn't characteristic of, say, C, C++, COBOL, Fortran, Pascal? Basic? Which basic? The differences between the basics over the years has probably exceeded the differences between many of our languages today, between C and Java, for instance. Big difference, yeah. The big difference in basics. Big difference between Java and JavaScript. They're not the same language. One is compiled into an interpretive language, a JVM. And then you have JavaScript that'll do a just-in-time fast compilation, which, Perl and Python do kind of the same thing, sort of. Then you have Go, which is this sort of in-between, but really fast language. You've got Rust, which is, tied in with immutable objects and things. You don't need to do the garbage collecting and all that because your variables are already, set up to be used properly, so you're not going to be getting your zigzag V's in your programs. And of course, who knows about those things anyway? The old people do. A lot of them. A lot of us. A lot of us have worked on we've gone through school, we've learned about things like building compilers, Lex and Yak and Bison, and, various tools, lexical scanning, all of these kind of things. The operating systems, the internals of operating systems, how to build operating systems, demand page virtual memory, how that's constructed, time-sliced multiprocessing, SMP versus other kinds of parallel setups, the networking, all of these different things. You don't suddenly lose everything and become dumb when you turn 40. But sometimes I think some of your managers who think a little bit too much of themselves don't take any time at all to turn dumb. When they start thinking of themselves in such superior terms that, I fire fast and hire slow and I'm brutal and mean and everyone is afraid of me because I am a good manager and I do management right. You toe the line, you do your part in, or I crack the whip and I say jump and you say how high. Or you don't wait to say how high, you jump anyway. And don't bother me with your questions about how high. And that is a sloppy-minded manager without a functioning brain. A good manager can respect his or her people. They care. And they do a good job. They don't do a sloppy job just cracking the whip all day. Nobody wants to live under that. If you're working for one of them, I pity you if you have to. If you feel that you must, that you're enslaved, that you can't get free from them. But I would recommend you do whatever it takes to get away from that. and get on to something better. Don't just run away. Run towards something. Find something to run towards. Find your dream. What do you love to do? What is your passion? What is your calling? What is your purpose? If you could spend, is there some time in your life where you've encountered a situation where you said, I could do this for the rest of my life. I love doing this. I feel fulfilled. I am contributing something valuable to the world. And this is wonderful. And I love doing this. I could do it every day, all day long, for the rest of my life. And as for family, I could bring them along and I could teach them too and get excited about it. I could breathe this into so many other people's lives. I could get them excited about it, and it wouldn't take anything because the excitement's in me. If you have that kind of thing for your career, you've got it made. You've really got it made. So go for it. If you want to do this, you want to do machine learning, you think of all the things you can do with machine learning. Driving cars, if you want to colorize black and white photos or black and white movies and have the AI do it for you, and you want to come up with these things, you want to come up with special effects, or you want to work with sound, acoustics, you want to design something that could design acoustics, you want to build guitars, you want to build, well, if you want to build a guitar, you don't have to go into all the technical things. You can become a luthier and do it that way and build and experiment, try to get a sound that you love, or you can try to design some different tools with electronics and with AI that will actually, predict the sound or engineer the sound of a guitar according to its shape, according to the materials, according to the different things. And then there's so much that you can do. If you want to make self-flying drones for a purpose, that you could basically say, okay, I'm going to put this house for sale, put this house up for sale. Somebody wants to put this house up for sale. Photograph it, video it, all around and inside. And you tell the drone, go. And it goes and it takes optimal pictures with the optimal settings, does it all, comes back, you look at it and say, that's awesome. And maybe it asks you for the titles and asks you for information to sell the thing, and maybe it makes a prediction for you what the house would sell for, or what you want to ask for it, depending on how fast you want to sell the house. There's all kinds of things you could think of. I mean, this may be weird or insignificant to you. It may not matter at all. But maybe something else does. If something else you have a passion for, maybe analyzing lungs for cancer, or breast cancer, preventing breast cancer, saving lives, foot cancer, I don't know, hearing loss, analyzing the eyes, analyzing teeth or the jaw structure, nasal structure, anything else that you might have a passion about. Just enjoy. Find something where you can contribute to the world and you can enjoy it. And you're bound to be a success one way or another, no matter how much money you have in your pocket from it. But you might also make a lot of money at it too. So go for your dreams. Don't let anyone convince you that you can't go for your dreams, or that it's stupid to go for your dreams, or that you don't have enough skill, or you don't have enough talent, you don't have enough intelligence, you don't have enough whatever. Don't let them shut you down. Naysayers are worthless. They will hold you back. Don't let them. Don't be their slave. Perhaps they have an insecurity, and your success threatens them. Don't let their pathology wreck your life. You don't deserve that. And other people don't deserve it either. They don't deserve to be missing out on your happiness and your success, because your success contributes to the well-being of other people as well. If you let that person, that naysayer, hold you back, you're going to deprive a lot of other people of what you can bring to this world. Don't be foolish. Don't let the naysayer have their way with you. Don't let them. I wish you the best. Okay. So how would you learn machine learning? Fast AI would be a good way to go. Udemy is a good way to go. Ubiquity is expensive, but if you're committed to going down that path, and you want to go down the path towards the certification, they will probably prepare you very well in that area and give you a very rounded education in it. If you go with Coursera, chances are you're going to get something rigorous, university, academically oriented, and it's going to be very, very tough, but very, very good if you're an academic person. If you're a person that you're a scientist, you want to get into and study it. That's what I did. I don't recommend that for everybody. I recommend something more functionally fun. Enjoy yourself. Enjoy yourself as you're learning it. But that fun happens in different ways for different people. Get a perspective, a lighthearted perspective. Watch something, a YouTube video that's fun. A Udemy course that's fun. Buy them on sale. Udemy has these things on sale all the time. If you buy them when they're not on sale, you might end up paying $100 for a course, or $200 or something like that, $150. If you get it on sale, you might pay $9 or $11 or something like that. And wait for it to be on sale. It's the best thing you could do, and you might rack up a whole bunch of courses like I did. And then now you feel obligated. I have to finish each one of those, because if not, I'm squandering the money and I'm not being a good, what's the term? I'm not being a good steward of that money that God's given me the ability to earn and have. And I'd be taking away from my family if I didn't go through and finish and do well. But there are courses, there are reasons for putting the priority in different areas. Now, I haven't completed my Coursera courses yet. I've got 2 more that I'm almost done. I've been kind of burned out on that. I needed to take a break and do other things. So I did photography. I learned a tremendous amount in photography, and I love it. And I'm using it for the websites that I'm building, like this one here. I want to flesh these out so that they are a benefit to people. So hopefully everything will go well. It's a little bit of a challenge not to get burned out, but when I do, I can migrate to something else. I need a lot of variety. My mind has to be active all the time. I sleep at night and everything else, sort of, but I've always got to be busy. I've always got to be moving ahead. I can't stagnate. It's just not me. And I like that. That's the way I want to be, and that's the way I want to stay. So, how do you learn machine learning? Dig in, have fun, play with it, explore the amazing free videos on YouTube, build your hunger for it, get excited about what it will do. Think about all the things it could do. Imagine, picture them. See the magic behind it. Get into Fast AI's free courses and learn one easy way to learn this stuff. When you're ready, dig into rigorous deep courses from Coursera's Andrew Ng, or Jeffrey Hinton, or Udacity. Udacity is also very good. I haven't gotten into that one yet, though. If you get stuck, consider some Udemy courses to get different perspective, but don't stay stuck long. Go for perfect scores. You really do learn more when you push for perfect scores rather than passing scores. Play around with Kaggle competitions and free courses there. That's a great way to do it. There are free MOOCs out there, ways of learning Python, machine learning, all these other things. Kaggle is really good. Kaggle's the best. Spend time mastering data wrangling. This is important. Data cleaning and pulling data from all kinds of sources, whether you're scraping from a website, which you need to be careful about because you need to make sure that you don't want to be hammering other people's websites or stealing stuff that they've accumulated and built up at their cost of their research. But if they're offering it out there free, and this is a legitimate source of information, and they say, come and bring in our data, you can come bring it in. But don't keep bringing in the same data over and over again every time you run this one program. Set up your program so they pull in the data once and store it. And if there's an update to be done, it'll pull in the updates and update locally. Pull in updates, update locally, and keep that path so you don't violate someone else or their website. You're not unkind to other people that are offering a service, a value to you. And then also make it robust so that if they shut down that service or make it happen a different way, you have a different source of information. Or you can benefit from the data you already squirreled away. Okay. If you get stuck, consider some Udemy courses to get a different perspective, but don't stay stuck long. Go for the perfect score. Play around with Kaggle. Spend time mastering data wrangling, getting it into form for the input for a neural net, the cleaning of the data, the pulling the data sets from all sorts of sources, and then learn engineering deployment of AI models into complete software engineering solutions to make those engineering solutions complete. So you can build from A to Z, you can deploy, you can update, you can maintain, you can have version control, say stuck on GitHub, or if you're doing, DevOps kind of things, you might want to get into Docker and the Docker Hub there. All of these kind of things kind of work together. But at least get to know GitHub. It's a very important thing. And what else? I guess the rest of it will all be in text on my website here. I'll try to include this video into my website. So anyway, I'm a geek that needs a challenge. So I've included several videos on this as well. And you can learn a little bit about Fast AI, about Andrew Ng. Lex Friedman is a cool character. You may want to get to know him. He interviews the greats, and he's a researcher out at MIT, quite brilliant. I have very little to say about him other than what is really good, because the guy is really a cool individual. Okay, well, I guess that's it for today. Thank you again for coming here. I hope this was useful to you. And thanks. And it's half an hour now. So, okay, bye-bye.